What's up, everybody? Today we're going to be focusing on converting from polar coordinates to rectangular coordinates and vice versa. Now, we already learned that the polar coordinate system, it coincides with the rectangular coordinate system, right? So if I have this point P that you see pictured here, if it is defined in terms of r and theta, it also has an associated rectangular set of coordinates in terms of x and y. So I could just use a little bit of right triangle trigonometry to relate r and theta with x and y here, right? We have a right triangle here. So I could say that cosine of the angle theta that's defining point P, it's equivalent to x over r. Solving that for x leads me to x equals r times cosine of theta. Similarly, if I were to find sine of that angle theta, it would be equivalent to y over r. Solving that for y, I end up with y equals r times sine of theta. So these are your two conversion equations that relate x and y with r and theta. Let's use them to convert 8, 5 pi over 3 from polar form to rectangular form. First, let's visualize this. I'm going to graph it. Okay. So that's my x-axis and my y-axis. I'm going to rotate from the positive x-axis, or the polar axis, 5 pi over 3, or 300 degrees, to get to my terminal angle. And we learned on the terminal angle, we should be counting, in this case, 8 spaces to get out to our point, right? Okay. So use the equations from above. The x-coordinate that matches that point is going to equal my r value of 8 multiplied by cosine of my angle 5 pi over 3. Now, to figure out the value of cosine of 5 pi over 3, I could reason out that this is a 60-degree reference angle, right? So let's draw that out. How about over here? That's negative radical 3. That's 1. That's 2. So cosine off of that would be 1/2. And 8 times 1/2 would give me an x-coordinate of 4. Similarly, to get y, I'm going to take 8 times sine of that 5 pi over 3. That's going to be 8 times negative radical 3 over 2, which simplifies to negative 4 radical 3. So in the end, we can say that the polar set of coordinates 8, 5 pi over 3 converts to 4, negative 4 radical 3. That describes the same point in rectangular form. Okay. We can label that in our picture here as well. We would say that this is an x value 4, and right here is a y value of negative 4 radical 3. All right, now let's go in the other direction, and this tends to be the more challenging direction from rectangular to polar. Notice the directions here. We're going to round to the third decimal place if needed, and we're going to express theta between 0 and 2 pi, which means we're going to need to think of theta in radians. Now, notice what I have in red here. I think this is extremely important. I want to always begin by plotting the point to see what quadrant it's in so that I can reason out a value for theta, okay? And you'll see what I mean by that as we move through these examples. All right, so the rectangular set of coordinates 2, negative 2, let me plot that point. That would be in the fourth quadrant. Okay, let me draw the right triangle associated with it. And first I'll go after my r value. That's going to be the easy value to find. You can just simply find it with x squared plus y squared equals r squared. So x squared would be 4, y squared would also be 4. That's going to make r the square root of 8, which is 2 radical 2. So let's label that in my picture. And then in this case, theta, it's I think it's pretty easy to reason out here from the picture. This is a 45-degree reference angle, right? And that means I need to express theta in this direction. That would be 315 degrees, or in radians, that's 7 pi over 4. Okay, so we'll say that 2 negative 2 from rectangular form converts to 2 radical 2, 7 pi over 4 in polar form. Okay. All right, now, notice I was able to do that example completely by hand, didn't need a calculator, not going to be the same for the next problem. I want to plot negative 3, 5, that's going to be in the second quadrant. Okay. All right, so let's go after r first. X squared plus y squared, once again, equals r squared. That's going to be 9 plus 25. And r is going to equal the square root of 34. All right, so I'm clearly not working with a reference triangle here, a special right triangle. So to find that angle theta right there that defines this point, I need an inverse tangent function. Okay, now why inverse tangent? Well, the point that I'm given right off the bat has an x coordinate and a y coordinate, which is perfect for inverse tangent. Inverse tangent of my y value divided by my x value. But we have an issue here. If I just leave it like this, inverse tangent of negative 5/3 is going to yield a fourth quadrant angle measure, not a second quadrant angle like this one is supposed to be in. It's been a while, but recall all of our inverse functions, they have range restrictions to them that only allow them to be in 2 of our 4 quadrants. So in the case of inverse tangent, you can only be in quadrant 1 or 4. Here it's 4 because the argument is negative 5/3. Okay, so think about this. If that is a fourth quadrant angle, it's going to be expressed as a negative value, and I want to think of theta as a second quadrant angle. In this case, all I need to do is add pi to that in order to come up with my actual measure for theta. Okay, so you'll need your calculator for this. If you were to find inverse tangent, make sure you're in radian mode. Inverse tangent of negative 5/3 is negative 1.030. Now that in itself clearly can't be our value for theta because of the directions that theta is supposed to be between 0 and 2 pi. But the bigger issue is not that it's negative, but it's in the wrong quadrant. So all I need to do is add pi to it, and I end up with 2.111. Okay, so we're going to say that negative 3/5 corresponds to radical 34, comma, 2.111 approximately in polar form. Okay. Now, this is extremely important for you when you go to complete your WebAssign assignment related to this lesson, okay? WebAssign is not going to want a decimal approximation for theta here. Instead, WebAssign is going to want you to input your answer like this. They're going to want an exact answer. So you'll type it in as the square root of 34, comma, inverse tangent of 5 over negative 3 plus pi. That's how you're going to want to input it. Okay, very, very important. All right, now I know it is not in your sheet. I decided to add this in for just a little bit more exposure, but I threw in a third example here as well. So this is the point 5, negative 3, which is in the fourth quadrant. Okay. And we're going to run into the same issue here of that this is not going to give us a special right triangle. Okay. So your r is going to be the same thing. It's going to be radical 34 one more time. And then your theta, let me write that out, r is radical 34. And then theta is inverse tangent of the negative 5/3. And now this time notice that theta, it is supposed to be in the fourth quadrant, right? Which inverse tangent of negative 5/3 is. The only issue is that inverse tangent of negative 5/3 is a negative value. It's expressed in the negative direction, right? So all I need to do in this case is add 2 pi to get a coterminal angle in order to keep my value for theta between 0 and 2 pi. Okay, so let me get an approximation for that. Inverse tangent, negative 5/3, added with 2 pi, that's 5.253. Okay, so 5 negative 3 in rectangular form corresponds to radical 34, 5.253 in polar form. Once again, WebAssign is going to want things in exact form. Write it or type it in like this for your assignment. Okay. All right. Good luck on the